Hello everyone, this is Professor Rathod from the Scholar Academy. So friends, today we are going to discuss very important topic from the organic chemistry, that is halogen derivative of alkanes and arenes. So from this topic, today we are going to discuss very important reaction, that is SN1 reaction. So first of all, you will see what is meant by SN1 reaction. Okay, so here S stand for substitution, N stand for nucleophilic, and 1 stand for unimolecular reaction. Yes, I love you clear what is meant by SN1 reaction. Here S stand for the substitution reaction, N stand for nucleophilic reaction, and 1 stand for the unimolecular reaction. So this SN1 reaction involves 5 steps. So now we see one by one. So first step is the hydrolysis of tertiary butyl bromide. Step first, that is hydrolysis of tertiary butyl bromide. Okay, you know the structure of tertiary butyl bromide. Just see the structure: CH3 single bond CS3, single bond CS3, and Br. This is the structure of tertiary butyl bromide. Okay, tertiary butyl bromide reacts with aqueous NaOH. You know the structure of NaOH, sodium hydroxide. This is in aqueous form. That means NaOH we can dissolve in water, so that's why it is called as the aqueous. Okay, when tertiary butyl bromide reacts with aqueous NaOH, so here NaBr is removed like this, Br from this NNA. Okay, NaBr is removed and this OH group is going to attach here. This is a nucleophile. Okay, and here we get tertiary butyl alcohol. This is the structure of tertiary butyl alcohol, CH3OH, and NaBr is removed. Br from this tertiary butyl bromide and Na from NaOH. So byproduct is the NaBr. So the name of this compound is tertiary butyl alcohol. Okay, if hydroxy group is there, that is the alcohol. So now we see the second step. Step second is the kinetic study. You know the chemical kinetics. Chemical kinetics is nothing but the study the rate of chemical reaction. Rate is nothing but the speed. Okay. So in kinetic study, what you have to see here, the rate of this reaction depends upon only tertiary butyl bromide, not the NaOH. That means whatever product here we get, tertiary butyl alcohol, that will depends only on tertiary butyl bromide. Okay, not the NaOH, because NaOH is in excess form. That's why this product depends only on tertiary butyl bromide, not the NaOH. So that's why this is the first order reaction. Okay, so here we can write rate is directly proportional to the concentration of tertiary butyl bromide. Okay, concentration of tertiary butyl bromide. Therefore rate is equal to, if proportionality sign goes, there will be the K. K is the proportionality constant. Rate is equal to K, concentration of tertiary butyl bromide. Okay, so therefore this is first order reaction. Okay, so here we can remember one important concept. Order of reaction always depends upon the reactant species. Okay, how many reactant is involved in any chemical reaction, accordingly order of reaction will be changed. If any reaction, two reactants are involved, that is the second order. If 3 reactants is involved, third order, like that. In this reaction only one reactant is involved, that is the tertiary butyl bromide. So that's why this is the first order reaction. Okay, all of you clear this one? So now we see the third step, that is the mechanism. That is very important. Mechanism of SN1 reaction, step third. Step third is nothing but the mechanism of SN1 reaction. Mechanism of SN1 reaction. So mechanism of this reaction involve 2 steps. Okay, so step first is the slow step, that is the RDS, rate determining step, and second step is the fast step. Okay, here we see in first step, so whatever tertiary butyl bromide you have to use, CH3 single bond CH3, we see the mechanism CH3, here Br. This is the structure of tertiary butyl bromide. So this is a fast step, this is a slow step. Step first is a slow step, and this is RDS, rate determining step. So in this first step, what happened, this bromine group is removed, this is a leaving group, and here we get the carbocation like this, CH3 single bond CH3 CH3. If bromine will be removed, then here plus sign will become, this is a carbocation, and plus Br minus, this is a leaving group. In first step we get the carbocation. Okay, so step second, now we see step second, that is the fast step. Okay, in second step what happened, whatever carbocation we get in first step, that will react with nucleophile. That means nucleophile will attack on a carbonyl carbon of a carbon atom of the carbocation. Here we see this carbocation, we can write here plus nucleophile from NaOH group OH minus. So this nucleophile will attack here. So this is the fast step. Okay, fast step, and here we get tertiary butyl alcohol like this, because this nucleophile will directly going to attach on this carbon, and here we get the tertiary butyl alcohol. This is the mechanism of SN1 reaction. All of you clear mechanism? So mechanism of this reaction involve 2 steps. So first step is the slow step, that is the rate determining step, which can determine the rate of reaction, that means speed of the reaction. So in first step what happened, so from this tertiary butyl bromide, this bromine will be removed and there will be the formation of carbocation. Okay, and in second step, whatever carbocation we get in first step, that will reacts with nucleophile. That means nucleophile, that is the OH group, will be attack on the carbon atom, and this is the first step, and we get tertiary butyl alcohol. So this is the mechanism. So now we see stereochemistry. So in this stereochemistry, what you have to see, whatever carbocation here we get, if that nucleophile will attack on the front side. If backside will attack, then what happen? Just please see in stereochemistry. That is the step 4th. Step 4 is the stereochemistry. Stereochemistry. Okay. So in mechanism, whatever carbocation here we get, this one CH3, you can write like this also. Okay, this is the carbocation. Okay, if nucleophile will be attack, that means OH group will be attack on back side as well as front side. Okay, here nucleophile will attack on front side attack. So this is the front side attack, and here back side attack. Okay, just we see if nucleophile, that is the OH group, will attack on front side, then what happens? So on front side, that leaving group is here, bromine group. If nucleophile will directly attack on the same place of the bromine, then there will be the no change of configuration. Okay, that means there will be the retention in configuration. Here we see this CH3 group like this CH3, this CH3 and this OH group. Okay, this is called as a retention in configuration. There will be the no change of configuration. R and S configuration does not change here. But in case of the backside attack, what happens? If nucleophile will be attacked here, just we see, then what happens? This position of CH3 group will be changed. If suppose instead of this CH3 group, other group will be there, then the position of this CH3 group will be changed. That means from backside what happens? Just we see this OH group will be attached on the place of this CH3 group. That means there will be the changing configuration. Okay, so that is the inversion in configuration. Okay, inversion in configuration. If backside attack takes place, that is the inversion in configuration, and if front side attack takes place, that is the retention in configuration. Okay, I hope you clear this one. So now we see the last point from this reaction, that is energy profile diagram. This is very important. Step 5. Last step is one. Step 5. This is energy profile diagram. Energy profile diagram. Okay, so here we see energy profile diagram. So the graph of reaction coordinate versus potential energy we can draw like this. Okay, this is the reaction coordinate, reaction coordinate, okay, versus potential energy, potential energy. This will be the graph. So we can start the reaction from here. So mechanism already have to see, there will be the two steps. That means there will be the two transition state. In graph just we have to show like this. So reaction will be start from here. This is a reactant. Okay, so we get the two peaks like this. That means we get two transition state. Okay, so and here we will get the product. So this will be the product. So why I have to show the two peaks here? Because this is the transition state first, okay, and this is a transition state second. This is the TS first. Because in mechanism already have to show there will be the two transition state. That means this reaction involved in a two steps. First step is the slow step and second step is the fast step. Okay, so here we get first transition state. So reaction will be start from here. We get the first transition state. That means, and here we get the carbocation. So in mechanism already have to see. Here we get the carbocation, and again nucleophile will attack, and there here we get the product. In second step, finally we get here product. Okay, delta H, and this highest peak is nothing but the delta E1, and this one is called as a delta E2. Okay, what is meant by delta E1 and delta E2? E1 and E2 is nothing but the activation energy. Okay, activation energy, that will be the highest peak from the reactant to transition state, that is nothing but the activation energy, and the distance from the product to reactor, that is the delta H, that is nothing but the change in enthalpy. Okay, if in some reaction delta H is negative, that will be the exothermic reaction, and if in some chemical reaction delta H will be the positive, that will be the endothermic reaction. Okay, so energy profile diagram, that is nothing but the reaction coordinate versus the graph of reaction coordinate versus potential energy is called energy profile diagram. Okay, so in this energy profile diagram we get highest peak from reactant to transition state. That highest peak is nothing but the activation energy. Okay, and the distance from the product to reactant, this one reactant product to reactant, is nothing but the enthalpy change. Okay, I have clear this reaction. So in next topic, in next lecture we will discuss the next important reaction, that is SN2 reaction. Okay, in next video we will see SN2 reaction. Okay, thank you so much.